assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So for this problem, we're given the scenario of a simple harmonic oscillator where there's a 0.5 kilogram block attached to a spring. The block slides back and forth over a frictionless surface, and it has an equilibrium point at position x equals 0. At time equals 0, the block is at position 0, and then it starts off first moving in the positive direction. And then we're given this graph here that shows both our position on our x-axis as well as the force, the magnitude of the net force on the block. And we see here that the force Fs is equal, we're told, is equal to 75 newtons. The first thing we're asked to figure out is what is the amplitude of this block. So we want to find our amplitude, so our xm, and we can do that just by looking directly at the graph itself. The amplitude is going to be where the block hits its maximum point, and if we follow that up from the graph, we can see that that is at position 0.3 meters. So our amplitude is just going to be 0.30 meters. The next thing we are asked to find is going to be our period. So we're trying to find the period of the oscillation. And we can do that if we start off with the equation period equals 2 pi times the square root of mass divided by our k, our spring constant. We'll be able to find the period. Now, the issue is we don't know our spring constant. So we're going to have to actually take this term and substitute another equation in for that. And we're going to, because we do know the force, we're going to use the equation force equals negative kx and rearrange that for k. So our k is going to equal negative force divided by our position. And again, looking up here at the graph, we can see that when we have our maximum force, we are also at our maximum position here. So we can substitute in these values. So we have a force of, or we have a k is going to equal negative 75 newtons divided by 0.30 meters, which gives us a k value of 250 newtons per meter. And we can now take that and substitute that back in up here for into our equation for our period. So we have T equals 2 pi times the square root. The mass of the block is 0.50 kilograms. Our K value is 250 newtons per meter. So we end up with a T value of T equals 0.281 seconds. So our period is 0.281 seconds. Next, we're being asked to figure out what is the acceleration of this block. So we're trying to find our acceleration here. And so we're going to use the equation acceleration equals omega squared times our amplitude. And we don't have our omega, but we do have the equation that omega equals the square root of k over m. So when we put this in for our omega, we will actually be squaring it, so that will help us because we'll get rid of the square root sign, and we will have acceleration equals k over m times our amplitude. And we solved for K earlier, and we had that K was equal to 250 newtons per meter. So now we can substitute in these values to find our amplitude, or sorry, our acceleration. So we're going to have acceleration equals 250 newtons per meter divided by 0.50 kilograms, all times 0.30 meters. And we get that that equals 1.5 times 10 to the second meters per second squared. So our acceleration is going to be 1.5 times 10 to the second meters per second squared. Okay, and lastly, we are being asked to find the kinetic energy. So the equation for kinetic energy is K equals 1/2 mass times velocity squared. And velocity is equal to omega times our amplitude. So that makes our equation become K equals 1/2 mass times omega xm squared. And again, we still don't have our omega, so we can swap out omega is our square root of our K, our spring constant, divided by our mass. And when we plug that in here, we get a final equation of kinetic energy equals 1/2 our mass times our K over m times our xm squared. And we can simplify this even further because our mass is going to end up dividing out here. So our final equation for kinetic energy will be kinetic energy equals 1/2 our spring constant times our amplitude squared. And again, our spring constant equals 250 newtons per meter. So when we plug these values in, we have our kinetic energy equals 1/2 times 250 times 0.30 meters squared, which gives us a total kinetic energy of 11.3 joules.